Last time, we sorted every unique word, big O of n log n. Today, the answer interviewers actually want. We only ever hold the top k, big O of n log k. The pattern? A minute heap, and one inverted comparator trick most people miss. 2 parts. Part 1 was the full sort. We are in Part 2, the heap. The optimal solve. Quick recap. Part 1 counted every word, then sorted all unique words by the compound rule, then sliced the first k. It works, but it sorts every single word, even when k is 1. That is wasted work, and a senior interviewer will press you on it. Here is the insight. At any moment, we only need to remember the top k words seen so far. Anything weaker than the weakest one we already have can be dropped on the spot. We never need to sort the whole input. The structure that matches that idea is a minute heap of size k. The top of the heap is the weakest candidate currently in the top k. When a stronger word arrives, we evict the top and push the new one in. After one pass, the heap holds the answer. Here is the tricky bit. The final answer wants count descending and word ascending, but the heap evicts the weakest first, so the heap comparator is the inverse. Inside the heap, weaker means smaller count, or on a tie, the alphabetically later word. Flip the direction in the heap, then flip back when you read the answer out. 4 moves. 1. Count every word into a map. 2. Walk each unique word and push it onto the heap. 3. If the heap grows past k, pop the weakest off the top. 4. At the end, pop the heap into a list and reverse it. That is the answer in the right order. The code in JavaScript. Assume a small min-heap class, push, pop, peek, size. Build the count map the same as part 1. Create a heap with the inverted comparator. Walk each unique word, push it in. If the heap is now bigger than k, pop the weakest. At the end, drain the heap with successive pops, then reverse the list. That gives the final order. Trace on the example. Words: I, love, leetcode, I, love, coding. K equals 2. After counting, 4 unique entries. Push I count 2, heap holds I push love count 2, heap holds love at the top because love comes after I alphabetically, and we inverted. Push leetcode count 1, heap overflows, pop leetcode, the weakest by count. Push coding count 1, overflows again, pop coding. Heap ends with I and love. Pop, reverse. Answer: I, love. The numbers. We walk every unique word once. Each push or pop on a heap of size k is big O of log k. So time is big O of n log k where n is the input length. Space is big O of n for the count map plus k for the heap. Faster than part 1 whenever k is much smaller than n, which is almost always. 3 traps that cost the offer. 1. The inverted comparator. The heap evicts the weakest, so its rules are the reverse of the final answer. Get the direction wrong and you evict the strong words and keep the weak ones. 2. The size check happens after the push. Pop only when the heap is strictly bigger than k, not equal to k. 3. Popping at the end gives the weakest first. You must reverse the pop list to get the answer in the right order. The pattern. Top k anything? Heap of size k with an inverted comparator. Shows up in word frequency, k closest points, top sellers, log analysis. Same trick every time. Subscribe at CodeBrainery. And drop the next coding problem in the comments. The number is enough.